Good day. Welcome back to our class. Today, let us continue discussing the chapter on atoms, ions, molecules, and the periodic table. So last time, I have already discussed with you about the atomic structure, the ions, and the molecules. So today, I'm going to discuss about the periodic table. Let us try to recall how this periodic table was developed and who were the chemists involved in the development of the periodic table. The chemists involved in the development of the periodic table were first, there was Johann Wolfgang Dobryner. This chemist formulated the Law of Triads. Now, what is this Law of Triads? He experimented that in a triad of elements, let's say we have calcium, strontium, and barium, the atomic mass of the middle element is the mean of the two atomic masses of the two other elements. So if calcium has an atomic mass of 40 and barium has an atomic mass of 137, then the mean of these two masses will be the atomic mass of strontium. And the atomic mass of strontium is 87. Then another chemist also helped in the development of the periodic table by the name of John Newlands. This John Newlands formulated the Law of Octave. In the Law of Octave, he concluded that the 8 elements manifested similar properties to the first element. In his periodic table, he listed the elements in terms of the relative atomic mass. By relative atomic mass, this refers to the ratio of the mass of an atom to 1/12 of the mass of carbon-12. And he arranged the elements according to the increasing atomic weight. Another chemist who worked on the development of the periodic table was Dmitry Mendeleev. The most prominent characteristic of Dmitry Mendeleev's periodic table is there were gaps between the elements as he listed in the periodic table. Why do you think so that he left gaps between these elements? These gaps were intended to be filled in when there are new discovered elements in the future. And according to Dmitry Mendeleev, he arranged the elements in the periodic table that he devised according to the increasing atomic weight. So the periodic table devised by Newlands and the periodic table devised by Dmitry Mendeleev have similarities in the sense that the arrangement of the elements was based on the increasing atomic weight. Dmitry Mendeleev published the periodic law, which states that the properties of the elements are a periodic function of their atomic weights. This is the reason why he arranged the elements according to the increasing atomic weight. Then came Julius Lothar Meyer. In the periodic table of Julius Lothar Meyer, there were 56 elements listed, and he arranged these elements according to the increasing atomic weight. And so it was similar to that of Dmitry Mendeleev that the elements were also arranged in the increasing atomic weight. But as he did this, he was able to discover that there was a mismatch in some of the elements when he arranged them in the periodic table. Then came Henry Moseley, who devised the periodic table in such a way that the arrangement of the elements in the periodic table was based on the increasing atomic number. So, of the five chemists who devised the periodic table, it was Henry Moseley who arranged the elements according to the increasing atomic number. For he said that the atomic number, not the atomic weight, is directly proportional to the square root of the frequency of the X-rays. So, the periodic law, which was devised by Dmitri Mendeleev, was changed by Henry Moseley. And this periodic law that Henry Moseley published, he called it the new periodic law. The new periodic law, which Henry Moseley published, states that the physical and chemical properties of the elements are periodic functions of the atomic number. So, the periodic table that is devised by Henry Moseley is the periodic table that we are now using. So, that is the brief history in the development of the periodic table. Now, may I ask you to take out your periodic table and kindly look at it as I discuss the parts and the elements contained in it. When you look at the periodic table, there are elements listed there together with their symbols, the atomic number, and the atomic weight. Now, how are these elements being grouped? There are two families of elements in the periodic table. These are the A family and the B family. For the A family, this includes the 1A, the 2A, the 3A, 4A, 5A, 6A, and the 7A. While the B families are those elements which are found between the 2A and the 3A families. If you're going to look at the arrangement of these elements, we have the vertical arrangement, which is called the family or the group, and the horizontal arrangement, which is called the period. The first period of the periodic table is composed only of two elements. These are the hydrogen and the helium. While the second and the third periods of the periodic table is composed of 8 elements. The fourth and the fifth periods of the periodic table is composed of 18 elements, while the sixth and the seventh periods of the periodic table is composed of 32 elements. Let's go back to the families in the periodic table. For the A families, these are the 1A family, which is known as the alkaline metals. These alkaline metals have only one valence electron. They can donate one electron when they form an ionic bond, and they have a low ionization energy. That's why it's easy for these elements to give up their electron or give up its valence electron. Next is the 2A family. This is known as the alkaline earth metals. These alkaline earth metals have 2 valence electrons. It can donate 2 electrons when it forms ionic bond. And they are less metallic as compared to the 1A family. Then there is the 3A family, which is known as the Boron family. This is composed of metals except boron, which is a metalloid. Their valence electron is 3 and it forms ionic bonds. The metals form ionic bond, but the boron forms a covalent bond. Then there is the 4A family. The 4A family is known as the carbon family. This family is composed of the nonmetal, the metalloids, and the metals. The nonmetal in this family is the carbon. The metalloids are the silicon and the germanium. Each element of the carbon family has 4 valence electrons, and they can form covalent bonds. Then the 5A family. This is known as the nitrogen family. In this family, there are 5 valence electrons, and this group contains a nonmetal, a metalloid, and the metals. The nonmetals of this family are the nitrogen and the phosphorus. The metalloids are arsenic and antimony. And the metallic element in this family is bismuth. Then there is the 6A family, which is the oxygen family. The oxygen family is otherwise known as the chalcogen. The chalcogen means ore forming, or they have the ability to form ore. This family is composed of the nonmetal, the metalloids, and the metals. The nonmetals in the oxygen family are the oxygen, the sulfur, and the selenium. And the metalloid is the tellurium, and the metallic element is polonium. The valence electron of the oxygen family is 6. Then there is the 7A family. This is known as the halogens. The halogen family has a valence of 7, and the name halogen is otherwise known as salt forming. This is composed of the fluorine, the chlorine, the bromine, the iodine, and the astatine. These halogens are salt forming. Then the 8th family is the noble gases, and they are otherwise known as the inert gases. Why? It is because they are unreactive gases. They are unreactive because they are already stable in their electronic configuration.